Good morning, everyone. Today we will see finding maximum and minimum in an array in design analysis of algorithms. Okay, we will see how to find maximum value and minimum value in a given array. The problem is to find the maximum and minimum value of n elements in a given array. So the input is only the array A of size n. It contains n elements. Output is the maximum and minimum of n values. So output returns two values. One is maximum of n values and another one is minimum of n values. We are going to find two values at a time. So this is the process of finding maximum and minimum in an array. We will see the example. So we have set of elements 5, 20, 18, 42, 64, 28 and 2. So the maximum value is 64 and the minimum value is 2. Take the second example 82, 45, 10, 86 then elements. Then in this array the maximum value is 86 and minimum value is 10. And linear approach, how to solve the problem using brute force approach. Normally how we are doing, so we have 7 elements in an array. Initially we are taking first array value, that is a of 0, assigned as max and min. Here in this example, the array first value is 50, 15 assigned to maximum and minimum. Next, the iteration starts from 1 to 6. There are two cases. If array element is lesser than minimum, assign array element as a minimum value. Else continue. And the second case, when you want to find out maximum value, compare array value with existing maximum. If array value is greater than existing maximum, assign array value to the maximum. So there are two cases. First case for finding minimum and the second case for finding maximum. So if I equal to 1, take the first value 25. So we are comparing 25 with min and max. If a of I is greater than max, assign a of I to max. If a of I is less than min, assign a of I to min. And otherwise, repeat the iterations, it will go to the next loop, next iteration. So if I equal to 2, max is 25, minimum is 18. So like that, we have to compare min and max value with every element in an array linear fashion. In linear fashion, that is from first to last one by one. That is linear approach for finding maximum. That is, we are taking the first value as min and max. So compare min and max value with every element in the array from 1 to 6 or in general 1 to n minus 1. If there are two cases, if the array element is greater than max, assign array element as a maximum. And if minimum value is lesser than array of a of I, then assign a of I to minimum. So that is the basic approach, linear approach for finding max and minimum. So in this case, see how many comparisons. Here the basic operation is comparison. We are taking the first value as it is, as maximum and minimum. So we are taking the remaining values, n minus 1 values in the array is compared with min and max. We comparing with min is one comparison, comparing with the max is another two comparisons. For each and every value of I from 1 to 6 or 1 to n minus 1, algorithm performs two comparisons. One comparison for finding minimum and one comparison for finding maximum. This is the linear approach for finding maximum. So in that case, how many comparisons? There are n minus 1 elements. Each iteration, there are two comparisons. So 2 into n minus 1. This is the time complexity of linear approach. So each iterations, two comparisons. So number of iteration is n minus 1. So n minus 1 into 2. That is the time complexity of Navy approach or brute force approach. This is a pseudocode. The input is array A of 0 to n minus 1. Array A contains n elements. maximum and minimum of n numbers. So we are going to find out maximum and minimum of n numbers in an array. So first input array A initially assigned first element as min and max. So initially A of 0, the first element in the array is assigned to max and min. Then the loop starts from 1 to n minus 1. So there are two cases. If array element is less than min, then min equal to A of I. If A of I is greater than max, then max equal to A of I. So this is a recursive function. This process is called recursively. After this, return max and min. This is a normal call. Returns max and min value to the main function. And stop. This is a general concept of linear approach. So see the algorithm. See the right side into main function. A is array. Getting size of array n. Next you are calling input array module. Input array. This input array parameter is a comma n. The array value and n number of values. So enter the number of values one by one. So for I equal to 0 to less than n. That is 0 to n minus 1. Print of I comma a of j. So normally index starts from 0. The 0th place first element. One element, there is first element. A of 1 is the second element in the array. So like that we have to compare. So then after getting input from the user, it will call the max and min function. So max and min function, so it compares A of I less than min, min equal to A of I. If A of I is greater than max, A of I is max equal to A of I. So that is the code. And what's the time complexity of linear search? Here the basic operation is comparison. There are n minus 1 iterations. Initially array first element A of 0 is assigned to assigned as min and max. So loop variable ranges from 1 to n minus 1. So for every iterations there are two comparisons. One comparison for finding maximum and one comparison for finding minimum. So this comparison operation is performed n times. Each time two comparisons. So the time find the complexity of max and min. Linear approach algorithm is T of n equal to 2 into n minus 1. So n minus 1 is number of elements in the array from 1 to n minus 1. For each element is compared with min and max. So for each element there are two comparisons. So 2 into. So 2 into n minus 1. So the time complexity is order of n. Next, we will see how to apply divide and conquer approach. Divide the given array into two parts till we have single element. This is a divide step of divide and conquer approach. It is a recursive algorithm. So first divide the array element into n by 2 and n by 4 and n by 8 until we have a single element. So next, find the maximum value and minimum value of left subarray. So here, after divide, the problem is solved and the results are combined. So solve and combine. So first, we are finding maximum and minimum for subproblems. Initial subproblems, then next level subproblem, next level subproblems, till we go to the root node that is to a given problem. So for each node, we are finding the maximum and minimum value for left subtree and find the maximum value and minimum value for right subtree. So these two values are combined to get the solution to the parent node. So compare the result of step 2 and step 3, that is left subarray and right subarray. So find the maximum and minimum of combined array. So return maximum and minimum value to the main function. This is the algorithm for finding max and minimum using divide and conquer approach. And see the example. So we have 10 elements. Initially, we are dividing this array into two parts, two equal parts, still we have a single element. So 10 elements divided into 5, 5. Again, 5 elements is divided into 3, 2. Again, the 3 elements are divided into 2 and the remaining is 2. So we are, after division, we are comparing the value of these two. Min and max for both left and side subtree. Then compare, find the min and max of the next level nodes. So in the last level, see here, the last level, we have 5 elements and we have 5 elements. that should be combined. So finding the maximum and minimum of left subtree and finding the minimum and maximum of right subtree. If you combine these two results, we can get the minimum and maximum value for the given whole array. So that is T of n. So in this approach, algorithm performs n log n. The analysis part we will see later. Next, how to find max and min using divide and conquer approach. So this is a recursive algorithm. See that code, void input array. There's a module for getting input from the user and print array. So after getting the value, we are printing the values in a with dimensions. So then it's a main function a of 100. So n, min and max. So enter the size of the array percentage d and a was an ampersand n. So next input array, call the function a comma n. So the array elements are print the values of array, and here this is a function called min max DAC, minimum and maximum algorithm using divide and conquer approach. So there are 5 inputs. So after calling the function will do some work that we will see in the next slide, and the minimum and maximum is assigned as the variable min and max. And this is a code for finding min and max. So if we have only one element, if I equal to j means we have only one element, the same element is assigned as min and max. So if array has only one element, so we can't compare with another element because it's a single element. So what we can do is we are checking the limit if I equal to j. So if the array has only one element, assign the first element as a minimum or maximum. Else j minus I equal to 1. In that case, we are comparing a of I with a of j. So whichever is greater, less than. So in the case of minimum, this a of I is assigned. In the case of maximum or false, a of j is assigned to max. Else we can have the same variable as it is. And so else find the mid value, that is left plus right by 2, and min max DAC is 1 mid and I mid and L min and L max. So again min max DAC, again the function call for right subtree. So A mid plus 1 J and address of R minimum, address of R maximum. So why we are using pointer variable for storing the result? So this algorithm returns 2 values. That value should be received and stored in the variable min and max. So this is the algorithm. So if n is 1, no comparison, t of 1 is 0. If there are 2 elements, t of 2 and find the max and min value for the given array using min-max DAC algorithm. And see the output, enter the size of the array, 6, enter the elements. The elements are printed, then the function will be called, recursive algorithm function will be called. So min is 6 and max is 88. This is the result of given array. This is very, very easy to implement. And analysis of finding max and min. So to find the time complexity of finding max and min using divide and approach, it is recursive algorithm. So the recurrence relation T of n can be written as if only one n equal to 1 first case. That is, if array has only one element, no comparisons, the same element assigned as max or min. So 0 means there is n value is 1. There's no more element. If the array has only one element. And n equal to 2. If the array has 2 elements, algorithm performs only one comparisons. That is the case. If you are finding the greatest of 2 numbers. So that is the finding greatest of 2 numbers. That is, it performs only one comparisons. Otherwise, if n is greater than 2, so 2 into t of n by 2 plus 2. So t of n by 2 is 2 into t of n by 2 is the given problem is divided into 2 sub-problems with size n by 2 and plus 2. Each iterations algorithm performs maximum 2 comparisons. So this is the recurrence relation for finding max and min. So the number of input is 1, there's no comparison. So T of 1 equal to 0. If n equal to 2, number of input is 2, algorithm performs only one comparison. So T of 2 equal to 1. If n is greater than 2, then apply divide and conquer approach. And the time complexity. How to find the time complexity for finding min and max. To find this time complexity of finding max and min using divide and conquer approach, it is a recursive algorithm. Recurrence relation can be written as T of n is equal to 0 if n is 1, 1 if n is 2, and 2 into T of n by 2 plus 2 when n is greater than 2. So how to solve the recurrence equation? Apply backward substitution method. So take the first equation. T of n is equal to 2 into T of n by 2. Because 2 subproblem with size n minus n by 2. That is 2 into n by 2 plus 2. This plus 2 is already there in the T of n equation. That is 2 iteration. 2 comparisons. One for finding max, one for finding min. And again find T of n by 2. So T 2 into T of n by 4 plus 2. So substitute the equation 2 in 1. That is a backward substitution method 2 in 1. And find out T of n by 2 value. And apply T of n by 2 in this equation. Find T of n by 4. That is 2T into T of n by 8. That is n by 2 power 3 plus 2. And so after finding this T of n by 2, substitute T of n by 2 in the equation, first equation, T of n equation. So our aim is finding the time complexity T of n. So T of n is equal to 2 into 2 power 2 T of n by 8 plus 2 power 2 plus 2. Again, 2 power 3 means 2 power 3 T of n by 8 can be written as 2 power 3 plus 2 power 3 plus 2 power 1, 1. So this is the time complexity of finding max and min using recursive algorithm. And how to solve this equation to find T of n value. So we have T of n recurrence relations. Then we will see how to find T of n value in general. So it will go like this: 2 power 3, 2 power n by 2 power 3. So next n by 4 T n, that is n by 4 value. So again T of n by 4 plus 2. And so how to solve this equation? N by 2 power k equal to 2. That is, if number of input is 2, the algorithm performs 2 power k iterations. So 2 power k equal to n by 2. T of 2 equal to 1. If array has only 2 elements, only one comparisons. So T of 2 equal to 1. So T of n is equal to n by 2 into T of 2 plus k minus 1 plus k minus 2 from k to 1. So this can be written as sum of series T of n is equal to n by 2 plus 1 into 2 power k into 2 power k minus 1 plus 2 power 1. So this is the fifth equation. So we are going to apply one term, sigma I equal to 0 to n 2 power I. Sigma represents continuous addition. So the equation value is 2 power k plus 1 minus 2. 2 power k plus 1 minus 2. Also, next, when we continue, n by 2 plus 3k plus 1 minus 1, 2. And we can split 2 power k into 2 power 1 minus 2. Again, solve the equations, find out the value. So t of n is equal to 3n by 2 minus 2, which is lesser than 3n. So when we find maximum and minimum value using using linear approach and using divide and conquer approach. So always divide and conquer approach is better than brute force approach. So time complexity of finding max and min. Linear approach. So that today often we conducted linear approach. T of n is equal to n minus 1 into 2. So T of n is equal to order of n. And divide and conquer approach, T of n is equal to 3n by 2 minus 2. This is also order of n. So both algorithm runs in order of n, but see how many comparisons difference If n equal to 7, the linear approach is 7 minus 1, 6 into 2, 12. And using divide and conquer approach for finding min and max, t of 7 equal to 3.7 into 2 by minus 2 equal to 21 by 2 minus 2, 7. So here in this approach, linear search approach takes lesser time compared to. So linear search algorithm works better, works worst than divide and conquer approach because number of comparison is more in linear search. So when we go for divide and conquer approach, so we can reduce the basic operations from 12 to 7 if n is equal to 7. So thank you.